Tonight is December the 31st, 2019. I have been thinking about it, working on and planning for it, buying and building for this AM transmitter for such a long time now. It's getting ridiculous. I've built several items. Here, I'll show you in the floor right now some of the things that I've already made videos of. There's the quad 1625 modulator. I've got the mercury vapor rectifiers out of it. This is a high level modulator that's going to run 810s. It's almost finished, but I don't know why I'm changing directions now. And here's the big 2500 volt power supply that uses 872 MV rectifiers. It's not that this will go to waste, it just doesn't seem to be going to be used right now. And another method that I've toyed with, and a good friend of mine has done this on a small scale, and it works. I've done this in a kilowatt level transmitter back, and it ended in 1975. That's when I left and I took the transmitter apart. But this works. This really works. And I'm going to show you this, how neat it is. It's just crazy. Well, this is a big Mac 2205. It's rated at 210 watts per channel. It'll do about 250 watts per channel, but we will be kind of nice to it. I've had it quite a long time. It's in beautiful shape. It's a monster. It weighs about 85 pounds. I finally did get a little cart to roll this stuff around because I just can't handle this stuff anymore. Especially 85 pounds of dead weight from the basement to the workshop here. But anyway, the meters are quite well calibrated. It's been years since I've calibrated them, but they've kept their calibration. So what I've done here, so I don't have to move the camera around too much, I'll just stand over here and point it out. I've got the two channels bridged parallel, and they're working in to this transformer right here. I've got two of these guys. A long time ago I used one in a modulator, and I ran the first one, which would have been this piece right here, which was a pair of 4400s. But now I'm just using this amplifier into this transformer. It doesn't have to be a transformer this size, of course. This came out of the best of my knowledge, came out of a ship-to-shore PA system. Probably 500 watts, ran a pair of 810s. I've used this thing as high as 4,000 volts, and it's never faltered. Anyway, what I'm doing is on the low impedance side, what it's got a whole bunch of taps. You kind of ought to see some of this. If you can see all these taps in here. These are all low impedance. The high impedance tap, this is a plate, center tap, plate. So this is high impedance side, this is low impedance. So what I've done is just juggled the taps around until I get the maximum amount out the other side for the loads that I have. Now the loads that I have are two that I've been working with tonight. One of them is a 10K, that's that big guy right there, and another one is a 600, is a 6500 that I've got adjusted down small so I can try with different loads. This is a 10K, it's at 225 watts. Well, let me just show you what it does, and we'll do a little bit of the math, and I think you'll get it right quick what the point is. Let's crank up the let's move this back out. Sorry for all the moving around, but it's kind of necessary. At least I'm not holding the camera and bumping it around too much. What we're doing is we're going to be measuring the voltage. I'll zoom in on it so you can see it with this meter right here. I've built a 10-to-1 voltage divider right here. This is a 1.09 gigohm resistor, and I got it in series with a variable resistor here so that I can calibrate it. so I can get exactly a 10-to-1 ratio. So we're going to be measuring voltages on the output of this transformer as high as 2,000 volts. I can't put 2,000 volts into my little meter there, it'll smoke it. So I divided it by 10 with the voltage divider. I know it's kind of hokey the way it's set up, but I've been very careful and calibrated properly, and it works really good. So what we'll do is this, and I think you'll find this interesting. First of all, we'll get kind of a reference point. Let's run the camera back down. Let's look here at these meters, and we're going to run it up to like 20 watts per channel. That's what I've been doing. Okay, everything's set up. Oh yeah, first thing I want to show you something. This will, before we even do that, I want to show you, excuse me, gotta reach over, the temperature of the resistors. See, this resistor is about 60 degrees. I think you can 57 degrees. You can probably read that pretty well. Okay, 57 degrees. Okay, but the first thing we're going to do is run this guy up right here, like I said, to about 40 watts, which would be 20 watts per channel. See, they're not calibrated exactly the same. This one's exactly on 20. This one's a little shy, so I've been splitting the differences. See, this one's a little below, that one's a little above. I'm averaging them out. So that should be about 40 watts. Okay, 40 watts. And what we do is we get back over here and we look up at this meter right here, and we see that it's 64.9, which is 649 volts. 649 volts is, you square that, E square of R, 649 squared, divide that by 10,000, and we get like 42 watts, 42.12 watts. So we can see our meters are calibrated quite well. Everything's doing what we expect it to do. Okay, now let's put this little devil to the test. I'm going to run it all the way up. Kind of wish I could just show you all these things at one time without having to move the camera around so darn much. I'm going to run this up. We're not going to, when the little red lights come on, we're going to back it off just a little bit. See how they're coming on? I'm going to back it off just to see while the green lights are on. We got to do this kind of fast because things heat up big time. Okay, now look at the voltage now. See, that's 197.9. Call that 198. That's 1980 volts. 1980 volts. Square that, divide that by 10,000. Oh my goodness. 1980 squared 10,000 divide. See, that's 392 watts. Is the camera focusing on that? Okay. 392 watts. So about 400 watts. And our meters down here are measuring just what they were a while ago, in a way. See, one of them is just shy of 200. This one's just was right dead on 200. So about 400 watts is what our Mac amp says we're developing, and we're measuring 392 watts. We're measuring, for all practical purposes, 400 watts. Now let's turn this guy down. Now if you have any doubt about the amount of power being pumped into that resistor, you saw what it was ago. Well, it goes about 59 degrees. Let's see what it is now. Can you see that? The glare of the camera. It's like 260 degrees or so. 270. Yeah, it's hot. It gets really hot really fast. That's a 225 watt resistor. Of course, I'm putting almost twice the power into it, so we can see that it's actually working. We got the voltage and we got the power. We got the meters that tell us, we got the voltmeters that tell us, and we got the heat. So it works. It'll work. I know it'll work because I've done it before. I didn't ever use a big Mac amp like this before, but here's really what we're dealing with right here. Let's get the camera over here. Crank it up a little bit more, just so I can get my hands in there, and I'll show you. It's so simple in a way. This is an audio amp. It can be any audio amp. It could be a 25 watt, a 50 watt, whatever. The amplifier size in watts needs to be about half, well, not about, but it has to be, for 100% modulation, it has to be exactly 1/2 the power of your Class C amplifier. It has to be Class C to plate modulate it. But you could use an 807 or a 1625 or whatever your favorite tube is. Build it right by the radio amateur handbook. Use your amplifiers. Say you got 100 watts. Say you're running a pair of 807s or even one 807. 50 watts, you use a 25 watt amplifier. And, you know, it's going to have a microphone input with a volume control. This one doesn't have a volume control, of course. I mean, it doesn't have a preamp, so I'll have to use some, for the microphone, I'll have to use some gain in there, some control into the amp. And then you put the 8 ohm, this would be, for all practical purposes, the 8 ohm output of your amplifier, and you put it into the 8 ohm side of another of a standard output transformer with something like 5K on the other side. It's not that critical. I can put this other resistor that's rated, that I've got adjusted to 6,500 ohms, and I get the same amount of power. I can juggle the low voltage, the low impedance taps around, and make it match just darn near anything. So all this is you could use just a standard audio vacuum tube audio output transformer. It could even have a center tap that you're not going to use. You just put it in backwards. You hook 8 ohm output of your amplifier to the 8 ohm side of your transformer, and out the other side you can see the kind of voltages you're going to get. You're going to get some serious voltage out here. And then out here, if you were just testing it, you would put a resistor across it, which is what we're doing right now, just for testing, to see how much power we can develop into this resistor. And the amount of power we can develop into this resistor is the amount of audio power in series with the high voltage. See, normally the high voltage wire would just come straight up into the amplifier. So in essence, you cut that wire in two and insert your transformer between it. So when you're not modulating it, when you're not speaking into it, the DC is just going straight on through. But when you start modulating it, excuse me, with your microphone over here, then you're superimposing on the plate voltage your audio, and your plate modulating the tube. Now I'm going to be using a triode. That keeps it simple. If you use a tetrode, you'll have to read all about it. You're supposed to modulate the screen somewhat. The best description I can tell you to find is to look, I'll put some links in this video, is to look at some of the old AM transmitters made by Collins Radio, and also get the iMac, one of the older iMac data sheets on the 4-125 tube, the 4-125A. They do a really good job of explaining multiple ways you can modulate the screen in case you use a tetrode. But if you use a triode, then there you go. That's what I'm going to use, because this amplifier is already built. This is built. That's built. It's basically all built. All I got to do to buy 833 amp, I'll go show you that right quick, just for a refresher, is to change the bias voltage and reconfigure it as a Class C amplifier. So let's go look at what I was going to do, and now you might understand why I'm planning on doing it like this. This is the amplifier, the 833 amplifier I'm going to be modulating. Right now it's configured, because of the bias way it's set up in the power supply, it's configured as a Class B single sideband linear amplifier. I don't have to make any changes to this. I'll probably have to tune it slightly different. I may have to, not sure what I've got to do to the tank circuit, because the plate impedance I think is going to be somewhat different. But that shouldn't be a problem. This is out of an old World War II ART-13, been around a long time. This is a B&W 852 tank coil, so that you can operate all 5 bands, although I don't really care about operating all 5 bands. I'm pretty well stuck on 20 meters. I finally got all of my amplifiers kind of put in order over here, so that I can keep up with them a little bit better, and what have you. Moved all this stuff around not too long ago. Got the transformers here. Yeah, there is a small problem in driving this 833, because I plan on driving it with this, but this is only 15 watts and that's not going to work. I also thought about using this one right here, this tank circuit, with a 4-125, but then, I mean, you can see I'm building stuff like crazy. But anyway, let me show you what I did. And this is the part that I bought this cabinet right here. This cabinet explicitly for this AM transmitter. Right here. This 19-inch rack. Put it together down here. And then I ended up putting all my calling stuff in there, and it is just so dadgum nice. I don't want to take all this stuff out. This is my favorite operating position now. I used a KWM2A. This is a 30L1. It'll deliver full 600 watts to the antenna. 51S1 receiver. There's just a speaker and a little watt meter I use. This is a peak reading watt meter. I've gotten really used to the peak reading watt meters. I love them. And that's just a power supply down there at the bottom. So you see, I was going to put the power supply here, the modulator, the amplifier, the exciter, however. But I don't want to do that now. So what I'm going to do is put it back in this cabinet right here. I'll put that Class C, that 833 back in this cabinet, which is what it was built for in the first place. And down here with the high voltage control, I can have 3,000 volts, 3,000, 3,500, or 4,000. And I can vary the bias. It uses some 866 rectifiers, but it's going to go back in here. Right now this has got a 3400Z homebrew amp in it that just works so good. Kind of hate to quit using it. I've got absolutely 3 completely and independent setups down here. One of them is this. I use this 3400Z with this little ICOM. You know, auto tune, you know, in case I want to be lazy and just run up and down the band. Then I've got the S-line stuff right here. The 75S3 receiver over here and the 32S1 over here. These are old ones. These are made back around 1959. These are some old ones. These two right here are now driving the big guy here. So I can get 1,500 watts out of it if I need to. And I've got some switching up here. The antenna's coming in here. I can switch it. This goes over to the KWM2A. This puts it in series here, and then it goes out through the other meters and what have you to either this one or or this set. I don't have the KWM2A set up here going through those meters, but I do have this little meter down here, and that's why I say I can measure 600 watts here, and then I can watch my modulation on this. Really like a peak reading watt meter. I've gotten used to them. Mostly I used the one that I built back in 1983, and then this little speaker up here is what goes to this this 51S1. Magnificent little receiver. But anyway, I'm working myself to death, and I haven't gotten anything completed yet, and I've built a lot of stuff that's probably going to go nowhere. But that's where it was supposed to go. So that's that. Now what? Well, back at the shop for just a second to close this out, but I will have to say, be very careful. You know, do this kind of stuff at your own risk, and keep other people away, and your pets and yourself, and don't get distracted, because the voltages that you can get out of this thing right here, just from, you know, what you think what is just an audio amplifier, but once you run it through a transformer and step it up, you can see it was right at 2,000 volts coming out. It would be quite a bit lower than that if you're running you know, 25, 50 watts, but still you got to be careful. This meter right here, what makes this one so valuable, I really can't say enough about it in a way, is first of all, it'll measure 6,000 volts AC or DC, and it's just one of those things that when you deal with high voltage, it's nice having a meter like this around, because when you see that meter sitting at half scale, that's 3,000 volts. That really should get your attention. I mean, if this thing, I mean, even 1,000 volts is right there. So, you know, if this thing is not on zero, you better be careful, because you could really get blasted. I was thinking about building a high voltage test jig using this resistor right here. I first set it up with a pot right here. Just a this is 2.5 megohm pot instead of using this, but I wanted to be able to dial it in and get it as perfect as I could, and it works quite well. Now you can't use these guys right here. These are for DC only. This is a 100 to 1. This is made for like measuring the voltage on old CRTs on TVs and stuff, where it's up at 30,000 volts or more. It doesn't work on the AC scale. I don't know what the input impedance of the AC scale is on these meters, but it's not 10 megohms fixed like it is on DC. And the way that I've got it set up right now, I can't actually put the 10 megohm pot, excuse me, the 10 megohm oscilloscope across it and look at it all at the same time, because even at 10 meg it loads it down. It changes my voltage divider ratio. So there you go. Anyway, we're gonna enter the new year of 2020. Seems like Back to the Future to me. I think I say that just about every time now. But be safe, and hope all of you have a wonderful new year of the year 2020, and are prosperous and safe, and we don't destroy our beautiful old planet. Thanks for watching.